Hello and welcome everyone for Intuitive Machines. Josh, it is so great to have you here today. I know.
Tahira, it is good to be back, and what a difference that 1 year can make. We're back out on the launch pad with another lunar lander and a maturing commercial space program that's ready to support commercial partners and, of course, NASA.
And we are so excited to be back on the launch pad with you. Liftoff of Intuitive Machines moon lander is scheduled for 7:16 and 30 seconds p.m. Eastern Time. And right now, everything is a go for launch. If all goes as planned, that lander will complete its journey about 8 days from now, with a landing at Mons Mouton, about 100 miles from the lunar South Pole and the farthest south ever attempted for a moon landing. One of the main goals is to gain insights into lunar soil characteristics and also detect resources beneath the surface. Josh, describe the build-up to this moment today. I mean, oh my goodness, for Intuitive Machines.
I'll try to sum it up for you. Back in the early days of the company, we started this mantra of, if people see your excellence and that you do the things that you say you're going to do, exceed those expectations. And after our first mission, we have some room to grow, and this moment is another opportunity to push that bar forward, get hardware to space, and show people what Intuitive Machines is capable of.
Well, I mean, you've already accomplished so much, so good luck tonight. Now, there are more than a dozen NASA and commercial instruments headed to the moon tonight, and we're going to walk you through them over the next hour and a half. But first, Josh, tell us a little bit about your spacecraft. We've got a replica of her right here that's sending all this new technology to the moon.
Well, first off, we love her, and her name
is
Athena, including her solar panels. She's just over 14 feet tall. With the landing gear, she's just shy of 15 feet wide. That's about the length of a standard car parking spot. The lunar lander weighs nearly 1,500 pounds and is capable of delivering about 220 pounds of payload to the lunar surface.
That is a lot of science, Josh. So, you know, we talked about having commercial instruments on board this lander. Can you walk us through some of those payloads on Athena?
Absolutely. Let's take a look at some commercial ones. We have Lunar Outpost Map Rover underneath the garage right here. We'll move this around. We have Nokia just on this side. And if we pivot back this way a little bit, you have Lone Star Data Holdings Data Center over here. But I want to talk about a payload that's helping us solve one of the challenges we found from IM-1, and that was regulating the thermal temperatures underneath the lander's top deck solar array, this area right here. So what we did is we partnered with Columbia Sportswear and brought in this material. It's called Omni-Shade Sun Deflector.
Can I hold it?
Absolutely. And what it does is regulate that extreme heat and extreme cold that the lander experiences underneath that top deck solar array.
Wow, that's incredible. And so all these commercial
Star Data Holdings Data Center over here, but I want to talk about a payload that's helping us solve one of the challenges we found from IM-1, and that was regulating the thermal temperatures underneath the lander's top deck solar array, this area right here. So what we did is we partnered with Columbia Sportswear and brought in this material. It's called Omni-Shade Sun Deflector.
Can I hold it?
Absolutely. And what it does is regulate that extreme heat and extreme cold that the lander experiences underneath that top deck solar array.
Wow, that's incredible. And so all these commercial payloads that you've been pointing out, they're all on the outside of the lander because, as I understand, Athena's fuel tanks are on the inside of the core structure.
You got it right.
Cool.
That's liquid methane and liquid oxygen tanks inside of the lander. What that requires is extremely cold fuel to be loaded inside of the vehicle. That fueling process started about 3 hours before launch, and fueling stops just before liftoff.
And what is really cool, to meet those requirements, SpaceX developed a way to fuel the lander while it's already attached to the rocket and on the path. Now let's head on over to SpaceX and Mission Control in Hawthorne, California.
Thanks, Tahira. I'm John Isbrucker, Falcon Principal Integration Engineer here at SpaceX.
And I'm Yomezo, a Lead Propulsion Engineer here at SpaceX. Now, IM-2 marks our 24th mission of the year after a busy 2024, where we launched a record-breaking 134 missions. SpaceX was honored to launch last year's IM-1 mission, which is the first commercial lunar lander to land on the moon, and the Blue Ghost 1 mission just last month. And we're excited to once again partner with NASA as part of the Commercial Lunar Payload Services Initiative, which you'll hear us refer to as CLIPS.
SpaceX was founded with the goal of making life multiplanetary, and today's mission furthers that goal by helping scientists understand more about the resources on the moon. We'll have more on SpaceX's part in building our future in space in just a few minutes.
Yeah, we're currently at T-minus just under 41 minutes from liftoff, and while the countdown continues, let's take a moment to meet the Falcon 9 that will be taking IM-2 to space today.
On your screen, you can see the Falcon 9 on Launch Complex 39A. Falcon 9 is a two-stage rocket, and it's the first orbital-class rocket capable of reflight. The first stage, the tallest portion of the vehicle, marked there on your screen, that provides 1.7 million pounds of thrust thanks to its 9 Merlin 1D engines.
That's right, and near the top of the second stage, powered by the Merlin vacuum engine, or MVAC, while this is very similar to the Merlin 1D on the first stage, this engine has a large nozzle which allows the second stage to perform more efficiently in the vacuum of space. Now, the first stage is what gets us out of the Earth's atmosphere and into space, and the second stage is what takes the payload to its targeted drop-off orbit. Now, that large barrel structure with the pointed nose at the very top of the vehicle is the payload fairing, and it's composed of two halves made up of carbon composite material that come together to protect the payload until we're in the vacuum of space.
Now, the Intuitive Machines landers need to be fueled on the pad with cryogenic methane and oxygen starting about 2.5 hours before launch. Now, ahead of the IM-1 mission last year, SpaceX teams had to modify Pad 39A and the transporter erector alongside the Falcon 9. We installed liquid oxygen and methane tanks, we put propellant lines in, and we put more of these to support the Intuitive Machine missions. Now, Athena, today's lander, went through the same late load of propellant while it was on the pad today. In fact, we have just finished wrapping up propellant loading. Now, methane isn't typically used in the Falcon program, so Falcon teams had to lean on the expertise of our Starship teams to verify the health and status of the lander and our fueling system.
And speaking of Athena, the lander arrived in Florida back in January, and since then, teams have been integrating the spacecraft to Falcon 9's second stage in preparation for a launch. It continues to be a smooth countdown today, and the SpaceX team will begin propellant loading at T-minus 35 minutes. Right now, we are looking good for an on-time liftoff, and in the meantime, let's check in with Tahira and Josh at Kennedy.
Thank you, Yome. Now, as we mentioned at the top of the show, there are more than a dozen instruments on board Athena.
And we're going to walk you through them to show you how they'll inform on how astronauts live and work on the lunar surface in the future.
So let's jump right into the NASA technology demonstrations. We have the Prime 1 suite, which stands for Polar Resources Ice Mining Experiment. It consists of two instruments, the Trident drill, which you see right here, and a mass spectrometer called ImSolo, which you see right down here. And joining us now live to discuss these two tools is Dr. Jackie Quinn, Prime 1 Project Manager with NASA. Jackie, thanks for joining us.
Oh, thanks for having me.
So let's start with this instrument right here, the Trident drill. Can you walk us through how this works?
So actually, this is a life-size rendition of the Trident drill. So that's the exact size that we're going to send to the lunar South Pole.
Big.
Yeah, it's actually was designed and built by Honeybee Robotics. It's a percussive augering drill, and it has the ability to sample down to a meter depth. So that's a little over 3 feet. And the way it works is it goes down in about 4-inch sections. It'll go down 4 inches. It'll collect the lunar regolith on the flutes of the drill. It'll bring it to the surface, deposit on the surface, and then it goes down again another 4 inches and deposits. It'll do that sequentially until it reaches its terminal depth. One of the very cool things about the Trident drill is it has a temperature sensor in the very tip of the drill. So as we're going down, we're going to stop and take temperature measurements at different depths along the way. So we'll get the first thermal in situ readings as we traverse down. That'll be one first. And of course, it's the first robotic drill in the lunar South Pole. So very cool.
That's right. A couple calls from SpaceX here.
Shuttle board the launch auto sequence immediately and proceeding to launch abort. At T-minus 10 seconds, launch shuttle will be hands-off and relying on automated abort criteria for the remainder of the count.
And Jackie, paired with Trident is the mass spectrometer ImSolo. I love the name. It's the second part of Prime 1. How are we able to use the drill in concert with the mass spectrometer.
Right. So actually, I have another life-size rendition. This is M Solo. So M Solo is a commercially available mass spectrometer built by Infocon, which the engineers and scientists here at the Kennedy Space Center have ruggedized for use in the harsh environment of space. So the M Solo works in tandem with Trident. When Trident brings up the soil and deposits it on the surface, the activity of depositing it gives enough energy that the frozen gas molecules are residing on the grains of the soil actually sublimate into the vacuum of space. And when that happens, the mass spectrometer, M Solo, is able to analyze the molecules and tell us which specific gases we're seeing and what quantity is there.
And so, Jackie, real quick, can you give us the big picture? You know, what does the Prime 1 suite contribute to the overall goal of long-term human presence at the moon?
Yeah, so right now, I would say we're fairly tethered to Earth as human explorers, and we want to be able to have a sustained presence on the moon, on Mars, on any celestial body. And in order to do that, we need to be able to live off the land. So if we look historically at explorers, say Lewis and Clark that went from Missouri to the Pacific, they were able to do it because they lived off the land. They gathered food and vegetables, they hunted, they drank water. Well, we as explorers of space need to be able to live off the land as well. And the way to do that is to be able to get the water if it's there, and be able to harness it for creating fuel and oxygen. And that's what Prime 1 will do, is to give us those first key engineering components that allow us to design future systems.
That is so exciting, Jackie. Thank you so much for joining us today.
Being here. Go Prime 1.
And it sounds like we also did just get a call out that RP1 propellant loading is underway. So that is a great update to hear. Now, also aboard Athena is the Laser Retroreflector Array, or LRA. It's a collection of reflectors. You can also think of them as mirrors that are designed to use reflected light from an orbiting spacecraft laser to help locate landers better on the lunar surface.
Tahira, this technology requires no power to work and has been used since the Apollo era.
And now we're looking forward to a new era of lunar exploration with NASA's Commercial Lunar Payload Services initiative. Here's why we're teaming up with American companies to deliver science and technology to the lunar surface.
Our moon. It seems so close in the night sky, but getting there is really hard. But what if there was a way to change that? Only a few nations have successfully landed on the moon. As NASA sends astronauts back to the lunar surface, this time to stay, we will need to send science and technology instruments ahead of time to lay the foundation for human exploration. To make this happen, NASA is helping establish a commercial lunar economy. For the first time ever, there will be commercial delivery services to the moon. We are enabling American companies to send our payloads to the lunar surface for us. These delivery services will expand our capabilities for exploration, radically increasing the amount of science we can achieve. This high-risk, high-reward initiative will invest in and leverage the entrepreneurial spirit of American innovation to launch a commercial lunar marketplace, advancing technology and exploration for all of us. With this never-before-seen streamlined access to the moon, we will be able to make novel measurements and develop technologies that scientists have long wanted to do on the lunar surface. And as this new industry matures, this commercial delivery service for NASA and other customers could expand beyond the moon to other destinations in our solar system. And we can learn to live on another world because we are explorers.
Josh, one thing that I think is super cool about tonight's delivery being led by Intuitive Machines is that it's controlled from your mission control, and it is a super unique setup.
That's right, Tahira. Let's take a live look at Nova Control. This is the nerve center of our entire program at Intuitive Machines. Starting now, we have 3 primary flight controller teams working 24/7 to monitor, command, and control our lunar lander during its journey to the moon and Athena's mission on the lunar surface. Here's a closer look at how Athena may accomplish her mission.
Athena's mission may provide the wisdom required to define How will humanity live and work on the moon?
These kind of questions, where we go from being observers of the moon to builders on the moon, this is the first step to beginning to answer those kinds of questions.
Her route to unlocking the moon's secrets follows the same path as an old friend.
Odysseus lunar lander separation confirmed.
Small engine firings refine Athena's trajectory before approaching lunar orbit.
We have to do what's called a lunar orbit insertion. It's about a 900 meter per second maneuver. It's a big burn.
In orbit, Athena checks on her payloads, including Lone Star's data center, and manages extreme heat in the light and frigid cold in darkness.
We're just going in orbit, doing the things you do with satellites. This will be very similar to what we do with our orbit and comm relay satellites, starting with IM-3.
A short engine firing sends Athena into a lower orbit to prepare for one final 600-second burn maneuver to the surface.
And it's a nice ride. The engine provides a steady level of thrust that does pick up a little bit as we deplete fuel, but we control it.
Finally, Athena's true mission, delivering technologies, science, and services that may enable humanity to live, work, and explore deeper into the solar system.
It's definitely a great feat. But once you're there, you want to expand from that landing spot and go and look at different things.
For approximately 10 days, Athena is designed to support NASA's Prime 1 drill suite, deploy a rover, send a rocket-fueled drone into a crater, and connect those spacecraft using Nokia's 4G LTE lunar surface communications system.
We have people that are driven to build and fly and operate space equipment, and that's what we're here for. It's who we are.
In addition to Athena, Intuitive Machines and NASA developed a first-of-its-kind technology called the Micronova Hopper for IM-2. We're joined now by Trent Martin, the Senior Vice President of Space Systems at Intuitive Machines, to talk about the Hopper. Trent, welcome.
Thank you.
So, I hear over at Intuitive Machines, y'all call the Micronova the Grace Hopper.
We do. We need Naharika Agarwal, our project manager for the Hopper, named it after Grace Hopper, who was a pioneer in software programming.
Well, what's such a fitting name for another pioneering technology? You know,
Absolutely.
Hopper had big support from NASA's Space Technology Mission Directorate through what we call a Tipping Point Award. Can you explain why that is? You know, what is it about Grace that has everybody so excited?
Yeah, so we had decided that we were looking for a technology that could be utilized to go to extreme locations on the moon. In particular, places that rovers couldn't go. We had settled on the Hopper, and we started working on the Hopper through a partnership with NASA through the Tipping Point opportunity. We were able to fund that, fly it to the moon, and prove out this technology, prove that we can go down into pits or down into permanently shadowed regions or even into the lava tubes on the moon.
Wow.
And once she's in a pit or a lava tube or a crater, what payloads do you have on board conducting the science that you expect to get back there?
Yeah, so this first mission, we didn't intend to have any payloads on this, but we actually have 3. So we have a camera system so we can look down, see what's underneath. Through a partnership with the German Space Agency, we added a temperature sensor, a pyrometer, onto the foot of the Hopper so that we can sense the temperature down inside of a permanently shadowed region. And then working with a company out of Hungary called Pulley Space, we put a neutron spectrometer on board so we can actually tell if there's water down inside of a PSR.
That is so exciting. Now, so you talk about Hopper going inside these craters, these lava tubes. Does she have to hop back out to transmit the data, or can she do it from right inside there?
Well, we believe that she's going to have to hop back out. However, partnering with Nokia, we've actually put a Nokia antenna on top of Hopper. And based on the analysis that Nokia has done, we believe that we will be able to communicate outside of that PSR that we're flying into just by bouncing the signals off of the walls of the crater. But we'll find out. That's part of the experiment.
How far away is that crater, and how many hops do you think it'll take to get there?
So we're going to take 5 hops once we get to the surface. 1 to get us off of the lander, and then several different hops to prove that we can fly parabolically, we can fly a steady level flight, we can fly down into the PSR, and then wait a period of time and then fly back out of the PSR. We'll be 700 meters away from the lander by the time we're finished.
It is so exciting just hearing about the complexities of, you know, this lunar technology that's going to the moon. And Trent, we wish Grace safe travels into the history books.
We do too. Thank you very much.
Thank you. Now let's head back to SpaceX in Hawthorne, California, where John and Yomi are standing by live right now.
Thanks, Tahira. Everything continues to be go for launch as we count down to liftoff in just 26 minutes from now. Now, not only is the Falcon family of vehicles supporting NASA's lunar efforts through contracts like CLIPS, but we're also working directly with companies to help support a growing commercial industry, and that's unlocking space for both commercial and government customers.
Yep, that's absolutely right. And for more than a decade, Falcon 9 has supported 45 missions to the International Space Station with our Dragon spacecraft, starting with our first cargo resupply mission, then returning human spaceflight capabilities to the U.S., and even helping launch 2 additional cargo missions with Northrop Grumman's Cygnus. All of these missions have enabled science and research to be conducted on the International Space Station.
Yep. A lot of work from low Earth orbit. Now, since 2022, SpaceX has supported the next generation of commercial space exploration. We've done the launch of 3 private astronaut missions to the space station, and that's been in partnership with Axiom Space. Now, in the near future, Axiom plans to attach a module to the ISS, and that will eventually detach and form an independent station, one of many commercial space stations that will come online soon, as well as after the International Space Station exits service at the end of its operational life.
That's right, John. And when ready, SpaceX will help deorbit the space station. NASA awarded SpaceX a contract to develop the US Deorbit Vehicle, or USDV, which is a modified Dragon designed to guide the ISS through a controlled re-entry into Earth's atmosphere. Now, this will be a pivotal moment in spaceflight history, and as the space station departs orbit and hands off the baton for future private missions like those from Axiom or VAST, which is working on developing space stations that launch directly into orbit. And you can see that on your screen right now.
Now, SpaceX's drive to unlock space does not end there. In 2021, SpaceX launched Inspiration 4 on a 3-day journey around the Earth. It was the first all-civilian mission to space. And missions like Inspiration 4 that you can see here, Polaris Dawn, and the upcoming From 2 mission, those allow commercial astronauts to conduct research and other activities in the microgravity of outer space, as well as demonstrate new technologies while orbiting the Earth. Now, as some of you may recall, last year the Polaris Dawn crew reached the highest altitude ever in Earth orbit since the Apollo program. They participated in the first ever extravehicular activity, what we call an EVA, where they stood up in Dragon wearing SpaceX-developed EVA suits. They also conducted 36 research studies and experiments designed to advance both human health on Earth and during long-duration space flights. There's a nice view of the very top of Dragon where they conducted that EVA from in the SpaceX suits.
Yeah, those were incredible missions. And all of these missions, including today's IM-2 mission, are helping set the stage for future missions to the Moon, Mars, and beyond. And of course, SpaceX continues to support NASA's Launch Services program with missions like Sphere X and Punch, which are currently scheduled to launch in just a few days. So very exciting times ahead. But back to today's mission, let's check back in with Tahira and Josh over at KSC.
Thanks, Yome. So we are at about T-minus 22 minutes from liftoff tonight. Josh, if all goes as planned, this would be the second lunar landing for Intuitive Machines. I mean, that has to feel good.
It does. And just last year, we became the first commercial company to land and operate on the surface of the moon, despite a harder than expected landing caused by a laser altimeter mishap.
Now, so what did your team do to assess IM-1 and really make modifications for this second mission tonight with Athena?
Right. After IM-1, the entire team met and reviewed every minute of the mission. What went right, what went wrong, and identified a few improvements for Athena. Namely, we've taken extra steps in testing to ensure Athena's laser altimeter is rock and roll ready to go, Tahira.
I mean, that sounds great, Josh. So let's talk about this landing site. The landing for IM-2 is at Mons Mouton. It's named after the award-winning NASA mathematician and computer programmer Melba Mouton, who contributed to the successful Apollo 11 moon landing. Mons Mouton is about 100 miles from the lunar South Pole, climbing nearly 20,000 feet high. That's about the height of Mount McKinley in North America. This mountain is also about the size of Delaware, stretching 2,700 square miles, and will be the southernmost lunar landing ever attempted. Now, Josh, can you break down what are the differences between the IM-1 landing site from your first lunar landing and the IM-2 site for Athena tonight?
Well, both of these sites are lunar highland areas, very similar when it comes to that. The IM-2 landing site is about twice as close to the South Pole than our first mission.
Why was Mons Mouton chosen? Was there anything specific that you all used to really narrow this down for IM-2?
That's a great question. I asked our scientists, and as we move closer to the South Pole, combining Earth and Sun visibility becomes more challenging. So we chose Mons Mouton because the Sun and Earth visibility enables a longer surface mission so that NASA commercial payloads may complete their operational goals. It also has a crater close by that we're targeting for Grace to explore called Crater H. We'll have to think of a better name for the next round of explorers that drop by.
Absolutely, Josh. That's so funny. Now, and those explorers could be, Artemis astronauts. The Mons Mouton area is also one of the potential landing locations for the Artemis 3 mission. It's a region no other crewed mission has ever landed or explored before. Here's a closer look at the type of preparation that goes into returning from the lunar surface in our Artemis Moon Minute.
Hey everyone, I'm NASA astronaut Christina Cook, crew member for the Artemis 2 mission. I'm here at NASA's Johnson Space Center in Houston, Texas, where the Orion spacecraft is closely monitored for mission control during flight. Speaking of the Orion spacecraft, teams are gearing up for another important exercise off the coast of San Diego, California. Underway Recovery Test 12, or as we like to call it, URT-12, is the third in a series of tests to make sure teams are prepared to safely recover myself, Reed Wiseman, Victor Glover, Jeremy Hansen, and the Orion spacecraft. On URT-12, a mix of NASA and stand-in astronauts will be inside an Orion mock-up, and Navy divers will practice getting them out of the capsule and into helicopters, which will fly them to a nearby naval ship. Teams will spend the week running through different scenarios, including a daytime or a nighttime splashdown. That's your Artemis Moon Minute.
For all Artemis updates and info on the Artemis 2 mission, you can scan the QR code on your screen or visit nasa.gov/mission/Artemis-II. Now, for more on SpaceX's lunar efforts, let's go back to John and Yomei live at SpaceX in Hawthorne, California.
Thanks, Tahira. As we mentioned earlier, Falcon 9 is the first orbital-class rocket capable of reflight. And in fact, this will be the 9th flight of this particular first-stage booster supporting this mission. Together, Falcon 9 and Falcon Heavy have completed more than 450 launches and over 380 reflights.
It's hard to keep track of the scorecard. And today, this booster will be attempting to land on our drone ship, a shortfall of Gravitas. And this would be the 100th booster landing on that particular drone ship alone.
That's pretty incredible. And rapid reusability dramatically reduces launch costs, which helps increase launch frequency and enables a wide array of new government, commercial, and scientific opportunities in space like this one.
Now, lowering the cost of access to space is helping take humanity's next steps into the solar system, whether it's in LEO, GEO, interplanetary, or even deep space. Now, when the costs are lower, government and commercial customers can launch more missions, which helps accelerate development. This also helps commercial satellite and private research customers afford to launch more projects to space, and that helps stimulate innovation here on Earth.
Absolutely. And missions like SpaceX's Transporter and Bandwagon rideshare programs help make access to space even more affordable by sharing the cost of a launch across many customers.
All of this is to say reusability is that key innovation that's making space more accessible for the industry as a whole. We just heard Stage 2 LOX load is beginning. We're right on time. But let's talk more about technology and innovation, and we'll head back to Tahira and Josh at Kennedy Space Center.
Thanks, John. Many of the technology demonstrations on board Athena, like Prime 1 and the Grace Hopper that we heard about earlier, were driven by NASA's Space Technology Mission Directorate. Now, some are NASA-supported experiments that are developed by private companies. We also call these tipping point awards. These tipping point investments are valuable, stimulating the lunar economy as activity increases on and around the moon. Now, to talk about these programs, these payloads and awards, we're joined now by Mark Thornblom, Deputy Program Manager for Technical Integration of NASA's Game-Changing Development Program. Mark, welcome. We're so glad to have you joining us.
It's great to be here. It's an exciting night.
Can you first explain, what is Tipping Point and what does it mean to NASA and our partners?
Sure. So a Tipping Point project is a true collaboration and partnership between NASA and an industry partner. We are seeking commercially led new space technologies that show a promise for the benefit of commercial missions and for NASA. And so essentially what happens is that both NASA and the commercial partner have identified a new technology that is ready to be matured and be tested and then infused in the commercial market. So both NASA and the commercial partner, they both put in money, they put in resources, expertise, test facilities if needed, they put their plan together, they mature the technology, they test it, and so in this case, send it to the moon, prove out that technology, and then be ready to infuse it into the commercial market for a future mission that both the commercial world benefits from and NASA benefits from.
And so there are two tipping points on this lander, right? And so we heard about one a little bit earlier, the Grace Hopper. Can you expand on how this might revolutionize, space exploration?
Yeah, so the word revolutionize is really perfect for this type of mission. In the past, almost exclusively planetary exploration has been done with wheeled rovers. And that's been great. They're incredibly reliable. They do their missions well, and we've benefited greatly from them. But we've got to the point now in the science investigations, particularly on the moon, where we need to get into those more hard-to-reach places. In this case, we want to get to the bottom of a crater. We want to get into those permanently shadowed regions where we believe that resources, water, and other volatiles are there that we can go and eventually extract and use. And so a wheeled rover would be impractical to think that you could get down those steep slopes, over those cliff edges, down into those extreme temperatures, and then back up, right? So the fact that you have a hopper that can come up, over, set down nicely, do the science it needs to do, and then safely get out of there really changes the game on where we can go and do science on planetary bodies. And it's not just applicable to the moon, it has reaches out towards Mars and beyond.
All right, Mark, I'll throw you a curveball.
Sure.
Can you tell us more about another one of these tipping point initiatives with Nokia that hopes to deploy the first cellular wireless network on the moon?
This is the one that seems to just light people up when you talk about it. It's so familiar. Nokia has done such a fantastic job of taking their terrestrial telecom 4G networks that connect billions of people and devices every single day. And they're packaging it for space, and they're going to use it on future Artemis missions and future human sustained presence on the moon and Mars and beyond. And so to get a 4G network and to get that high-speed data, voice and datacom, and have your kind of local internet connecting all your devices up there really is an important part of meeting communication requirements for a human mission. So this demonstration is going to teach them a lot about what they need to do to collect that data. The environment is obviously very different. You're in a vacuum environment, the temperatures are different, the regolith's going to play. So the way the network responds will be a little bit different on the moon than here. So they need to collect that data so that they can go back and optimize their systems and be ready to deploy on a human mission.
Yeah, I think revolutionize was the right word for these two payloads. This
Absolutely.
is incredible.
Awesome, Mark.
Josh, so how is this integrated onto the Athena spacecraft then?
Well, Nokia's network in a box is mounted high up on one of Athena's closeout panels, and she has two antennas on top of Athena, and it connects both of those lunar mobility vehicles that we're talking about exploring the moon's surface.
All right, well, thanks, Josh, and thank you so much, Mark.
Absolutely. Thank you for having me.
Thanks for joining us. Now, when things get busier on and around the moon and Mars, astronauts and robots are going to need a way to stay in touch with each other. Here's a deeper look at how the Nokia tipping point will provide a communications network to help prepare us for that future.
On Earth, a cellular network has many components: base stations, radio units, and a core network that manages the connection between users and the network. Nokia's technology miniaturizes and integrates all of these components into a single network in a box.
This is Nokia Bell Labs Network in a Box that you can hold in your hands. It contains every single component that make up a 4G LTE network. Scaled down to this size, weight, and power, we could install it onto the Intuitive Machines Nova Sea lander along with specially designed antennas. Every gram that we send to the moon matters. While compact, the system also has many redundancies and fail-safes, allowing it to recover and heal itself. We also overhaul the system software to minimize the impact of ionizing radiation that would normally cause sensitive electronics to malfunction.
The network links directly to devices in both the Lunar Outpost Map Rover and Intuitive Machines Micro Nova Hopper. For the mission to succeed, this network must be fully autonomous. It must deploy and configure itself once on the lunar surface. As the lunar rover goes about conducting experiments, and the hopper goes deep within a crater, the network must also constantly make adjustments to ensure it maintains connectivity.
This is an uncrewed mission. There will be no human technician to tweak or repair the network if something goes wrong. Achieving that level of autonomy was a monumental task to undertake. Working with NASA's Space Technology Mission Directorate, Nokia plans to test the first cellular network on the moon. Success will have implications far beyond this important mission.
While Nokia's lunar network technology will be the first deployed on IM-2 mission, it's also being adapted for Artemis 3.
That's right. Now, these high-speed capabilities will be incorporated into the Axiom Space's AXEMU spacesuits, enabling connectivity on the lunar surface. You can think of this as our explorer's own cell phone network, but on the moon. Together, efforts like CLIPS and tipping points are helping advance humanity's reach into our solar system and shape our country's approach to exploration through commercial partnerships.
Tonight, Intuitive Machines' lunar lander is taking NASA's science and technology demonstrations to the moon under the Commercial Payload Services Initiative, or CLIPS, as we like to call it in the business, right?
Exactly, Josh. And under CLIPS, NASA asked commercial companies like Intuitive Machines to provide lunar delivery services that advance capabilities for science, exploration, and the commercial development of the moon.
Tahira, it's through CLIPS. NASA selected Intuitive Machines to deliver its Prime 1 drill suite and laser retroreflector array to the moon. However, Intuitive Machines added commercial payloads like the Diamond Yaoki rover, Puli Space Water Snooper, and others to make commercial lunar ambitions a reality. And it's by collaborating with NASA and leveraging CLIPS as a springboard, we've developed services for delivery, data transmission, and infrastructure that commercially develop the moon. Not just for us or NASA, but for all.
Absolutely, and it is an exciting time, Josh. So tonight is also the third CLIPS delivery that is launched on a SpaceX Falcon 9 rocket. Let's send it back to John and Yome at SpaceX in Hawthorne, California, as they walk us through the final moments of the countdown. We will see you after launch.
Now, as we mentioned at the top of the program, Falcon 9 is enabling these launches of the moon, including the Hakuto R mission, IM-1 a year ago, Blue Ghost, and Resilience, and of course tonight's IM-2 mission. Now, beyond the primary payloads, ride shares like the 3 additional payloads you can see, well, you can't see here, it's below the lander, but those ride shares will be helping to build the lunar economy. All these missions are something that Yome is going to talk about.
Yeah. Thanks, John. Yeah, all of these missions are developing our future in space and helping to support sustained human and robotic activity, including scientific research, resource extraction, and infrastructure development. Now, you should be able to see here some of today's rideshare payloads on the stack there just below the Athena lander.
Now, NASA's Lunar Trailblazer is also hitching a ride today, and we'll learn more about that later in the webcast, as well as Astroforge. They're an asteroid mining company flying its Odin spacecraft, which is headed towards the near-Earth asteroid 2022 OB5. Gotta love some of those asteroid names. And finally, Epic Aerospace's Chimera Orbital Transfer Vehicle, which is what is known as a space tug, a vehicle that works in space to help payloads move to their desired altitudes. And we'll learn more about these in just a bit.
Yeah, these systems are paving the way for our sustained presence both in space and on the moon as we deliver landers, crew, satellites, and rovers in the next few years, building up the moon's equivalent of low Earth orbit, which is known as lower lunar orbit, which will act as the staging point for future missions, supporting lunar communications and providing platforms for science and research.
And in the near future, reusability will extend all the way to the moon, with reusable landers flying their first missions. Frequent, low-cost launches from the moon will eventually allow for lunar exports, like metals and helium-3, which can help support future deep space mission to Mars and beyond. We're coming up at T-minus 5 minutes. Let's turn our attention to Falcon 9, the spacecraft. The good news is all systems are currently a go for on-time liftoff. We just heard the call out. The tanks are pressurizing. We're stiffening the Falcon 9 up in preparation for strong back retract. The strong back is the structure you see on your screen right behind the Falcon 9. You're looking right now at the payload fairing, inside of which Athena, the lunar lander, and the 3 ride shares are located. We also have had the transition to internal power for the spacecraft. That happened several minutes ago. Also, we were talking, we heard some of the call outs.
Strong back retract is running.
There's strong back retract begin to run. We have finished loading fuel on the first stage. We are loading liquid oxygen on the second stage, so we are on time, not working significant issues. What we're waiting to see right now is the 2 clamp arms from the strong back begin to open up. I think we can just start to see it now. Takes about 16 seconds to retract. Following that, we will then begin to recline the strong back away from the Falcon 9.
Yep, and you can see those clamp arms are opening as we speak. The vehicle is nearly fully loaded with propellants and will complete at the T-minus 2 minute mark. The range is also green and ready to support today's launch. And if for any reason we do not launch today, we do have a backup opportunity tomorrow at 7:11 p.m. Eastern Time.
At this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Falcon 9 uses 2 propellants. One's a refined form of kerosene called RP1, or Rocket Propellant 1, and we also use LOX, or liquid oxygen, as our oxidizer. Now, fire generally needs 3 elements to ignite: heat, fuel, and an oxidizing agent, in this case oxygen. That's the fire triangle. In our case, the liquid oxygen is chilled well below its boiling point. That makes it denser, and that means basically we can load more of it into the rocket.
Yep, and the third part of that fire triangle is a chemical known as TTEB, or triethyl aluminum and triethyl borane, which we use as an ignition.
Stage 1 lock load complete.
There's that call out for stage 1 LOX load complete. And the combustion of RP1 and LOX is what makes the rocket go, and it's that TTEB mixture that sets the match to the propellant mix.
Now, in addition to finishing LOX loading on the second stage in about 30 seconds, we'll have another major event at T-minus 60 seconds, and that's Falcon 9 computers going in startup. The autonomous first and second stage internal flight computers will take over the countdown. Inside of T-minus 2 seconds, we'll light the Merlin 1D engines for liftoff. And right now, though, coming up on T-minus 2 minutes, the Intuitive Machines payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket.
Currently, the weather is green, and the range is ready to support a T0 at 7:17 p.m.
Stage 2 lock load complete.
Okay, we've heard the call out just inside T-minus 2 minutes. Locks load on second stage complete. You can probably also hear the background enthusiasm. Everybody is getting ready for a launch to the moon. Next major event coming up right now.
Ground gas closeout.
Ground gas closeout. That means that strong back alongside the Falcon 9. We're draining any propellant from the ground lines. We're venting gas overboard. That'll also create what's typically a large white plume that comes off of the strongback. The cold, gaseous oxygen we're venting off of the strongback mixes with that warm Florida air, and you get a large white cloud, and you can see it streaming away. Waiting for the call out for startup of the flight.
United startup.
You see and hear it. We're in startup. Everything looks good. We're going to get the LD go for launch. And with that, let's pause for a minute and listen to that go.
LD, go for launch.
Right on time. Always love to hear that call out. T-minus 30 seconds and counting. All systems are go for launch of Falcon 9 with the Intuitive Machines lunar payload.
T-minus 15. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon, go Intuitive Machine.
Vehicles pitching downrange.
And looking forward to the number.
Falcon 9 carrying IM-2's lunar lander Athena has successfully lifted off at pad 39A. We're heading to the moon. We heard the call out of the pitch kick. That's a small tilt of the vehicle. We're still going pretty much straight up, but now we're also slowly heading horizontal.
You heard that call out for power and telemetry nominal, and once we reach orbital altitude, we're going pretty much horizontal to the Earth. The rocket needs to go about 17,000 miles per
Falcon
hour.
9 is supersonic.
Horizontally. We heard that call out. We are supersonic, and in just a few moments, we will pass through max Q, or maximum aerodynamic pressure, on the booster.
Max Q.
We're through max Q, and the Merlin 1D engines have throttled back up to full power. Next call out we ought to hear is MVAC chill. Falcon 9 data is continuing to look good as the first stage heads out over the Atlantic Ocean. Trajectory looking good on Falcon 9. Now we're going to have a few events coming up in quick succession. We're going to start with MECO, main engine cutoff. That's the point during the flight where we shut down the 9 Merlin 1D engines on the first stage. Then we'll go into stage separation, and then SES-1, which is the second stage engine start number 1.
And shortly after MECO, stage 1 and 2 will separate from each other, with the first stage booster beginning its trip back down to Earth, while the second stage engine starts for the first time, known as SES-1, where the single Merlin vacuum engine on board the second stage will light up. This is happening in just a few seconds.
MECO.
Stage separation confirmed.
And back ignition.
Call-outs of 3 good events. You heard it, and you should have seen it there on the webcast. MECO stage sep and SES-1. Now the first stage is not powered, it's shut down. Great views coming from the second stage cameras as we have just had sunset a little while ago at Kennedy Space Center. The first stage is now coasting to apogee. That's the view on the left side. We're slowly turning using cold gas thrusters. We're turning to orient the engines into the direction of flight. Also, you may have been able to make out in a little bit of the light, the titanium grid fin deployment is underway. We're using pneumatic gas pressure.
Confirmed.
And here comes fairing separation. And a beautiful view. Looking at Athena and the ride shares on top of the second stage stack. So we had good fairing
Vehicles are on a
separation.
nominal trajectory.
Trajectory's nominal. First stage is looking good as it coasts to apogee. Second stage under power. Yome, everything continuing to look good right now on the mission.
Yeah, we are at just over T plus 4 minutes into today's mission. IM-2 is SpaceX's 24th launch this year, and we are currently in the first of 2 planned MVAC burns. Around the T plus 6 minute mark, you should see on your screen the first stage's entry burn. It's currently making its way back down to Earth. And for that entry burn, we will relight 3 of the M1D engines on the first stage, starting with the center engine, followed shortly by the engines next to it, which will slow down the vehicle as it passes back into the Earth's atmosphere. Now we need to slow down the first stage to reduce re-entry forces, which will help us recover and reuse that first stage. And you can follow along on your screen to the telemetry on the bottom left and right of your screen for the stage 1 and stage 2 speeds and altitudes.
Now you may have noticed on the left side of your screen, first stage altitude has begun dropping. We have reached apogee, and now we are under the pull of gravity, headed back down to the Atlantic Ocean. Now to slow us down, we'll use that entry burn. And that means we're firing 3 Merlin engines to decelerate the Falcon 9, but we'll still be moving very rapidly. And that's going to cause the vehicle to fly through the Merlin exhaust gases. It's also known as the rocket's plume. And this will deposit a layer of soot on the vehicle surface, one of the signatures of a flown booster. Now that soot comes from the carbon-based fuel that Falcon 9 uses. Now it took us almost 2 minutes since separation to get up to apogee. It's going to take the rocket just as long to bring the first stage back down to the edge of the atmosphere for the entry burn coming up in just about 20 seconds or so. Now, as a reminder, the first stage that's supporting today's mission is performing its entry burn for the 9th time. Falcon 9 is the world's first orbital reusable rocket. This is important because it's that reusability that allows SpaceX to refly the most expensive parts of the rocket, and that in turn drives down the cost of space access.
Stage 1 entry burn startup.
Stage 1 FTS is saved.
There's that call out for entry burn startup, and this will be about a 30-second burn, slowing that first stage down as it re-enters the Earth's atmosphere.
Stage 1 entry burn shutdown.
There you can see the end of that entry burn on the first stage. And on your right, you can see the second stage still in the first of 2 planned burns, carrying the Intuitive Machines 2 payload to the moon. Now coming up next, we will shut down our MVAC engine on the second stage, followed quickly by the landing burn on our first stage. And the second engine cutoff of this first burn will be in just about 30 seconds at the T plus 7 minutes and 46 second mark.
Stage 2 is internal guidance.
You can see on your bottom right the speed of the second stage accelerating as we are in that burn.
Stage 1 transonic.
Stage 2 STS is saved.
MVAC shutdown.
There's that call out for MVAC shutdown. We should be getting a confirmation of a good orbit as
Stage
well as
1 landing burn.
there is that stage 1
Nominal
landing
parking
burn.
orbit.
and that confirmation of a good orbit on stage 2. Let's watch stage 1 come back home.
Landing leg deploy. Stage 1 landing confirmed.
Awesome views of that first stage landing. There you have it. That was the 413th recovery of an orbital class rocket, including first stage landings for Falcon 9 and Heavy.
Oh, first stage is back on the drone ship. Beautiful mission. Second stage is in the parking orbit in our low Earth orbit. Now the mission does continue in space with stage 2. Coming up next, we have the second burn of our MVAC engine. We call that SES2. And that'll be the second stage burn around the T plus 36.5 minute mark. And we'll follow that with spacecraft separation. Until then, we're going to send you back to Tahira and Josh at Kennedy Space Center.
Thank you, John and Yome. If you're just joining us, welcome to the Space Coast of Florida, where we just witnessed live the beautiful liftoff of the moon-bound Intuitive Machines lunar lander named Athena. It launched on top of a SpaceX Falcon 9 rocket from Launch Pad 39A right here at Kennedy Space Center.
Intuitive Machines is an American company based in Houston, Texas. We developed and built a complete space program around our lunar lander that's carrying, among other things, several NASA payloads. And if everything goes as planned, in 8 days, Athena is expected to land at the Mons Bhutan region of the moon, about 100 miles from the lunar South Pole.
That is right. And make sure you stay with us tonight. Our broadcast here on NASA Plus will continue through Athena's acquisition of signal, which is expected to happen just after 8 p.m. Eastern Time. Now, Josh, besides Athena calling home for the first time, are there any other big milestones that your team is monitoring and waiting to happen right now?
Well, it's important to remember that Athena making that first phone call home isn't an easy feat. The lander's designed to make a lot of autonomous decisions throughout the process, including getting into max power attitude. That's one of the first things flight controllers will confirm after we hear from Athena for the first time. They'll be checking that her top deck solar array is locked in, pointing right at the sun. And Tahira, one of my favorite parts of this mission is while Athena is expected to call back to mission control, there's more action. Additional payload deployments from the rocket's second stage.
I am super excited for that too. I don't think I've seen multiple rideshare payloads, release, and they are called ride shares. And while they aren't hitching a ride to the moon with Athena, they are on the same rocket, and Intuitive Machines has 3 of them, including the Lunar Trailblazer, which is managed by NASA's Jet Propulsion Laboratory. It's the only NASA science investigation on this mission that will not land on the moon. Once it deploys, it will orbit the moon about 60 miles from the surface to help scientists better understand the lunar water cycle. It will also inform future human missions as to where supplies of water may be found and extracted as a resource. The mission is managed by NASA JPL, and its science investigations and operations are led out of Caltech University. And we are joined now by Dr. Rachel Klima, Lunar Trailblazer Deputy Principal Investigator, to talk in more detail about Lunar Trailblazer. Now, Rachel, first though, what a launch tonight.
Oh my gosh.
Were you able to witness
Yes,
that?
I was. It was, my mind is blown, not just because the launch was so beautiful, but like to have worked on something for so long and see it go, I don't know how this is my life.
Congratulations. Absolutely. Can you tell us a little bit about the goal of the Lunar Trailblazer mission?
Sure. So Lunar Trailblazer, we proposed it in 2018 to follow up on some of the observations that were made almost about a decade before that of water on the surface of the moon, across the entire surface of the moon. So we're going back to study the form, the abundance, the distribution of that water, and to understand whether the water actually migrates across the lunar surface so we can characterize this lunar water cycle.
Wow. Tell us a little bit more about the science instruments on board that help you achieve that mission.
Sure. So the way that we're doing that, we have 2 state-of-the-art instruments. We have one called the high-resolution volatiles mineral mapping, mineral moon mapper, excuse me. I'm a little excited.
It's a proper government name.
Yeah. Atrium cube is what we call it by. And that studies the near-infrared reflected light from the sun. So the sun shines the light onto the lunar surface, And the light that's reflected back off basically carries with it like a spectral fingerprint of where water and minerals are on the lunar surface. So we'll be measuring those, and then riding along with that is the Lunar Thermal Mapper, which is out of Oxford University in the United Kingdom, and that was supported. So it's an international partnership with the UK, and they're measuring the temperature of the lunar surface at the same time that we're measuring the spectral signature and understanding where the water is.
Now, Rachel, quickly, can you tell us how does the work that Lunar Trailblazer is intending to do lay the groundwork for what we want to do with our Artemis?
Well, so, we have these hints of water on the lunar surface in the permanently shadowed regions of the moon and also on the illuminated surface. But if we want to go there with Artemis, if we want to live off the land, if we want to use the water that's there, we need to understand where it is. We need to understand how much is there. And so Lunar Trailblazer, on a scale that people can actually operate on, will be able to map whether there's ice in the permanently shadowed regions and that kind of thing. So to help pick landing sites and see where we want to be.
Wow, that is crazy. What an exciting future. Thank you so much for joining us, Rachel.
Thanks, Rachel. Okay. All right, thanks very much.
Now, Josh, I understand that there are a few other commercial rideshare payloads that, like Lunar Trailblazer, will deploy from the Falcon 9 rocket after Athena.
That's right, Tahira, and you can see it at home in this animation. Athena separates, and then the 3 rideshare payloads deploy. This animation has a condensed timeline. We actually expect the payloads to separate about 5 minutes after Athena.
Wow, I mean, even the animation, this is gorgeous. This is going to be such a spectacular view. So can you walk us through, what exactly is deploying here?
Well, what you're watching are all of the rideshare deployments, including Astroforge, a space mining company, using this mission to scout its target asteroid that is out of this world, and deployment of Epic Aerospace's payload called Chimera. It's an orbital transfer vehicle intended to deploy multiple payloads after separation.
And is there a special reason, that these ride shares joined Intuitive Machines' CLIPS lunar launches?
That's a great point. And Intuitive Machines takes an Apollo-like trajectory to the moon. It's called a translunar orbit. It's like throwing a fastball right at the moon. It enables Athena to get there in about 8 days, but for ride shares, it's an opportunity to get into a high-energy orbit to get places like the moon or a deep space asteroid like Astroforge. It's also an opportunity to send our future lunar data relay satellites on the same launches as our lander missions, starting with IM-3, which is, of course, also carrying our CLIPS payloads from NASA.
That's right, and IM-3 will be Intuitive Machines' 3rd lunar delivery mission as part of CLIPS, an initiative where NASA and American companies have teamed up to explore the moon. Now, a lot of research needs to happen before humanity can live and work on the lunar surface. And these CLIPS missions are like our stepping stones towards creating that sustainable future. In the end, the rewards outweigh the risks.
Landing on the moon is hard. We're going back. Under this Artemis program, we're going to be sending humans to the moon for the first time since Apollo. So ahead of humans, we want to get up as much science exploration and technology experiments as possible.
So CLIPS starts facilitating a lot of the early science, the things we want to learn before we even send humans. CLIPS stands for Commercial Lunar Payload Services, CLPS.
The services part is the key element. Ordinarily, when NASA delivers a payload to the surface of the moon, they do it with a commercial partner, but NASA controls the building of the vehicle. Now, we're buying the service of delivery of our lunar payloads to the surface of the moon.
It is a delivery service, akin to a delivery service that you'd have here on Earth.
NASA will provide payloads to a commercial company. They decide how to get it to the moon. They have to develop their own lander, but they also have to manage the entire end-to-end mission.
It's meant to provide affordable, rapid, frequent access to the lunar surface through American companies.
We're funding different companies.
We have commercial companies that are competing to win task orders to deliver our payloads to the surface of the moon.
One of the goals when we started CLIPS was to help establish a lunar economy.
Somebody has to do it first, and then it becomes commercially available. Then they're able to crank them up. Then they're able to make it more affordable. And so the lunar surface is just the next frontier for a commercial environment.
But we had to acknowledge up front, all the way through the highest levels of the agency's leadership, that some of them will fail. These missions may not be as successful as a traditional NASA mission.
We have accepted the risk that going through this innovative approach with these commercial companies, that there could be some failures. Some of them are new companies. None of them have ever successfully landed on the surface of the moon. So they're going to learn lessons.
We need to give our vendors the opportunity to learn.
And so that'll help ultimately buy down our risk as these companies learn, okay, what does it take to actually build up the lunar lander, integrate payloads, get to the lunar surface and land safely.
They've been able to demonstrate that they have very, very good technical depth and the ability to design and execute missions. We're willing to take more shots on goal. And we aren't risking human life. And in the big picture, if we're flying missions at 1/10 of the cost of a NASA mission and we fail 2 of them, we still get 8 missions for that same price.
Even with 1 or 2 or 3 failures, this is still a very economical proposition. It's a risk posture which is more risk tolerant than NASA is accustomed to. There's not a single one of these companies that's willing to bet their mission on a coin toss. Every one of them is doing what they can in order to have the most successful mission possible. But the important thing to realize is that risk tolerant does not mean risky. And the rewards are a long-term ability to get payloads to the moon inexpensively, frequently, and rapidly.
We want science, so we can then put more of our resources on even more science, exploration, and technology payloads and get more of a return on investment when we get to the moon.
CLIPS provides tremendous benefit across the scientific and economic communities.
So there's a lot we'd like to learn about the moon to help human habitation and prepare us for missions to Mars and beyond.
So the moon is the first step.
Joining me now are Dr. Nikki Fox, the Associate Administrator for NASA's Science Mission Directorate, and Dr. Joel Kearns, the Deputy Associate Administrator for Exploration. Now, Nikki, Joel, what a launch tonight.
Wasn't it beautiful? I know.
Does it ever get old?
No.
Never.
Absolutely not.
Never.
Oh,
Never. No.
Particularly when NASA science is going to the moon on it.
I know, right? It's more than just a launch. Like, think about, again, the future. So to talk a little bit about the future, Nikki, I know you're very passionate about how science can enable exploration.
Yes.
So can you talk to us about how the investigations and science going up tonight are really going to enable humanity having this long-term presence at the moon?
Yeah, I mean, obviously, science enables exploration, but exploration enables science, and that's why we're so excited about having this partnership as we move forward. NASA science does great science wherever we go in the universe, literally. From the center of the sun to the edge of the universe, we're doing fantastic science. But the really cool thing is when what we're doing is really enabling humanity to take next steps. And so as we return to the moon, we're not just returning to the moon for a short trip, we're returning to stay, and then the moon lights our way to Mars. And so all of the experiments that we have that we're putting on CLIPS are just there to enable us to do the next great things for humanity.
And so, Joel, as part of CLIPS, it is really to team up with American companies to help advance the capabilities of the commercial development of the moon. Can you explain how this CLIPS initiative and these flights are really advancing what we want to do with Artemis?
Well, every one of these CLIPS flights, like the IM-2 mission, is advancing both science and technology that we will need to move humans out further into the solar system, but also answer really long-term scientific questions we've had for decades since Apollo. And we're doing this a very different way than we did Apollo.
Yeah.
In Apollo, it was a national effort that was really done by NASA with a major industry at the time. Here we're partnering with our international partners, but also, as you said, with commercial firms in the U.S. And the way we implement CLIPS to carry out these science and technical objectives, we actually get as a service from U.S. industry the ability to bring things to the moon and get data back. This not only allows us to do this faster and less expensively, but it builds a capability in industry to take things to the moon, not just for NASA, but for all of our Artemis Accord signatories and all our allies and friends around the world. It starts with robotic landers, it goes to orbiters, and it goes to other small spacecraft. And you know that we are doing public-private partnerships now, even for the big human landers and the spacesuits. It's really the wave of the future for the moon and eventually Mars.
Absolutely. Now, very quickly, this is a hard question, but what are you both looking forward to most in this new era of lunar exploration?
We are going to go to places on the moon, again, to get ready for Mars and to answer questions about the moon that no one's ever visited before. So, for example, IM-2 on this mission will go the furthest, closest to the South Pole that anyone has ever been. And we know we want to send our Artemis astronauts to the South Pole. So just by going there, we're going to get the first information of what is the South Pole really like as we answer those scientific questions.
And Nikki?
all of our NASA science missions are super interconnected. So the exciting thing for me tonight is not only intuitive machines going to land, but Lunar Trailblazer, coordinated science, both of them looking for volatiles, really fantastic. NASA science doing amazing things all through our universe, from the just everywhere we go, incredible science. So just really excited to continue to inspire the world and lead the nation in science exploration.
Absolutely. Thank you both so much for joining us.
Thank you.
As part of CLIPS, Intuitive Machines is continuing to add commercial lunar services. It enables delivery, data transmission, and infrastructure to support the Artemis campaign and the commercial development of the moon.
2024 redefined Intuitive Machines, becoming the first commercial company to land and operate on the surface of the moon.
Houston, Odysseus has found his new home.
And rapidly advancing services for lunar data transmission and infrastructure.
When we jumped off on this CLIPS initiative and pivoted the company towards the moon, it pushed the boundaries of what could be possible. And so we thought unconventionally.
Last fall, we continued development of our lunar terrain vehicle, the Moon Racer, wrapped up 2024 with NASA astronaut testing at Johnson Space Center, along with a meteor crater trial run in Winslow, Arizona. To support delivering Moon Racer and other heavy cargo, the company completed several milestones in developing its heavy cargo lunar lander, Nova D.
So what we're able to do with heavier cargo is provide a logistics supply chain to the moon.
And while 2025 starts with another lunar liftoff, development of the first lunar data relay constellation capable of 4K video transmission is underway to support Artemis missions to the moon.
Starting with our third and fourth CLIPS deliveries, we plan on deploying data relay satellites and begin operational capability for Artemis and allow for more robust communication from the surface.
Each mission is building the foundation for a sustainable presence on the moon and a foothold toward the next step into the solar system.
We're now going to step aside while we await our next big milestones, the second burn of the second stage of the Falcon 9 rocket, and then separation of Intuitive Machines' lunar lander. We're expecting that to happen about 8 minutes from now, so we'll see you then. Welcome to Kennedy Space Center, where we are currently awaiting the second burn of the Falcon 9 second stage and separation of Intuitive Machines' lunar lander. This comes after a successful liftoff of the Falcon 9 rocket with the Intuitive Machines lunar lander named Athena at 7:16 and 30 seconds Eastern Time tonight.
And in approximately 8 days, Intuitive Machines expects Athena to deliver her cargo to the Mons Bhutan region of the moon, the southernmost lunar landing attempt in American history. But first to hear it, the lander has to separate from the launch vehicle's second stage.
And for that, let's go back live to SpaceX in Hawthorne, California, where John Innsbrucker and Yomei Zhu are standing by as we await that second burn and then spacecraft separation. John, Yomei?
Thanks, Tahira. We are a couple minutes away from our second and last relight of our MVAC engine. That'll happen at T plus 36 minutes and 25 seconds. And the second burn will last just over 60 seconds, and you can watch the velocity increase on the display on your screen.
All right, there we saw a little bit of solid oxygen drifting off. We're actually purging everything. We're getting the engine ready to relight, chilling it in. At the same time, we've been using little cold gas thrusters to just kind of push all the propellant down to the bottom of the tank, so it's right over the inlets of the turbo pump. So we're ready to pull it in when we start to spin the engine for burn number 2.
Well, and that's called set, right? And we use nitrogen to perform those maneuvers. And we can't see those thrusters that John mentioned. They're on the right on the main second stage, and we just have the MVAC engine view here. But you can see that engine chill process happening. You can also see the payloads on the left-hand side of your screen.
Oh, and there's a nice view. We've got a second payload camera on this flight, and I think we're looking right up at the business end of Athena with the large nozzle.
Yeah, really cool views. I love how Athena looks like a star when it floats away. Now again, we are coming up on that second engine startup 2 in just a few seconds here. Again, this will be about a 60-second burn.
MVAC ignition.
That's the call out for MVAC ignition. It's always cool to see that MVAC nozzle start glowing in the middle of the burn. We are about 30 seconds into our 60-second planned burn on the second stage, carrying Athena and the rideshare payloads to the moon.
MVAC shutdown.
There is that call out for MVAC shutdown. We've completed that second burn of the second stage. Just waiting on confirmation of
Nominal orbit insertion.
There is that confirmation for a good orbit, and it looks like we are on track for spacecraft separation in just a few minutes.
It's been a great launch so far. Coming up 38 minutes since we had the liftoff. And now we're waiting for that IM-2 lander to separate from Falcon 9's second stage. A little bit of a recap while we're waiting for that. That comes in a little under 6 minutes from now. We had an on-time liftoff shortly before 7:16 p.m. Eastern Standard Time from Launch Complex 39A at Kennedy Space Center. Everything has proceeded nominally. 2.5 minutes into flight, we got stage separation. We also saw the successful landing of Falcon 9's first stage on our drone ship, a short fall of gravitas, and that made the 9th landing for this first stage. Now, about 2 plus 7 minutes, 46 seconds, we had a successful second stage engine cutoff, SECO 1, and we heard the call out of a good parking orbit insertion. Now, that was the first of 2 burns of the second stage engine, and we just saw the second burn of that engine complete, and we also are in a good transfer orbit right now. Pay attention on the bottom right to the altimeter. We didn't change altitude very much during the 1 minute burn, but you can see we're starting to move away from Earth now. Now the vehicle is coasting at this point in time. Payloads are still attached as we're counting down towards the separation of the Athena lander. Now currently the second stage is in a coast phase, as I mentioned. We are essentially making sure everything is quiescent on the stage. We're venting down pressures. We're making sure that overboard vents are done so that nothing, for example, burps during flight. We want Athena, when we send the separation command from the flight computer, to just be moved away with the power of the springs and not have any jostling if, say, the second stage inadvertently vented something at that time. So we're making sure everything is quiet on the second stage. And we're coming up, we're under 4 minutes to separation, and we're getting great views of the second stage as it prepares to separate the IM-2 lander to begin its 8-day journey to the moon. And of course, given the way spacecraft want to be oriented to the sun, for example, make sure when they separate, they get power on the solar cells. If you're wondering why we have a camera pointed right at the sun, well, that's a requirement of the customer to make sure that the spacecraft gets nice and warm, gets a lot of power, everything looks good. And we talked about the 8-day journey to the moon. The Athena lander is carrying science and technology investigations from CLIPS that will help pave the way for humans to live and work at the moon. And today's mission is the second CLIPS mission for Intuitive Machines. Now we're waiting right now, separation coming up a little under 3 minutes. Getting some more views. We're cycling, the flight computer is cycling between the various cameras on stage 2. Got a view of the nozzle. As we heard earlier in the broadcast, that'll make a large maneuver as they get to the moon. But right now, everything is quiet on the lunar lander. There's a view of the nozzle extension one side. Here's the other camera at the back end of the second stage. The silver blanket that you see there, that's multi-layer insulation. We put that over the back end. That keeps all the valves underneath and the electronics warm and cool. Warm from the chill of darkness and the vacuum of space, and also helps insulate it from the hot radiative plume when we fire that second stage engine.
Got some cool views of the sunrise on the coming up from the Earth's horizon over there, which is very cool. Very cool to see.
"42 minutes, everything continues to be nominal on the second stage." Now, just to give you an idea of where we've been, where we're going, in about 1 minute, we are going to get deployment of Intuitive Machines 2 lunar lander, named Athena. We had the launch. We got into orbit with the first burn of the engine you see there on the screen. We just finished the second burn about 5 minutes ago, and we are in a coast phase on stage 2, making sure everything on the stage is quiet, do final vents, and then make sure that the stage is very stable, it's not moving around. And then we'll see deployment. It'll be interesting. I'm not sure which camera views we're going to get at deployment. Now, once we do the deployment, we then start another sequence that takes about 3 minutes and 50 seconds, and then we will get to the rideshare deployments. We'll have one, and then every 20 seconds, and then 20 seconds after that. Right now, we're just counting down, waiting for deployment. So let's listen into the countdown now.
there is that deployment. You can see IM-2 Nova C lunar lander named Athena floating away from Falcon 9's second stage, confirming spacecraft separation. Now, from all of us here at SpaceX, we are wishing the IM-2 lander a good flight and safe travels. SpaceX is honored to be a part of NASA's Commercial Lunar Payload Services Initiative to deliver science and technology to the lunar surface, and we thank NASA and the Intuitive Machines for entrusting us with today's historic mission to the moon. Now, while we wait for the next development, let's bring in Tahira and Josh back at KSC.
Yo, man, that was absolutely gorgeous. What an excellent throw from SpaceX to Hero. What do you think of that shot?
It is unreal, literally. It's so gorgeous.
Right now, we're going to continue to listen in simultaneously. We have Intuitive Machines Nova Control in Houston, Texas. That's going to be waiting for acquisition of signal. That's Athena's first call home, while also monitoring SpaceX.
FM, can you call out when we should have booted? And then if we get close to Confeder, give us a call.
All right, that's Intuitive Machines mission control
Athena
confirming
separation confirmed.
Athena separation confirmed. And to hear while we stand by and keep running this clock for about 5 minutes after launch vehicle separation, that's when we expect Athena to make that first call home. At the same time, John, I, and Yome in Hawthorne, California will be calling out those ride-share deployments.
And Com and Raven, let's
The views
tell
on screen.
Scuba to stand by, and let's focus on Singapore and Tina.
Yep, on screen you're looking at Intuitive Machines Nova Control on the left, and you're looking at the second stage views on the right with SpaceX, Tahira.
Just gorgeous views. Look at that Earth. That's us.
Absolutely incredible. A lot of things are happening right now. It's a very dynamic situation waiting for those rideshare deployments. Let's just listen in here.
AU permission back to TMAC for a second.
Here we go.
Those calls you just heard are the ground net stations that you're looking at right now inside of Nova Control, waiting for the ground stations on Earth to acquire Athena's signal. We're standing by in Houston for Athena making that first call home, standing by in SpaceX Hawthorne for waiting for those 3 rideshare deployments. We expect all of these things to be happening simultaneously.
And Josh, right now from Hawthorne, we should be about 30 seconds away from starting that sequence of rideshare deploy. First up should be Astroforge's Odin. 20 seconds after that, Lunar Trailblazer. And then 20 seconds after that, Epic's Chimera. Odin deployed, as you heard over the net.
Status, Odin's away.
Lunar Trailblazer, separation confirmed.
Lunar Trailblazer away.
We heard the call out in the acknowledgement. Lunar Trailblazer separated. Wait about another 10 seconds, and it'll be Chimera.
Com, we will have an
Chimera
OEM for them. Priority right now is
separation
Singapore.
confirmed.
Chimera away. All spacecraft are separated.
4 minutes, 15 seconds past that.
All right.
Now Josh Tahira, Falcon 9 second stage has sent its commands. Everything successfully deployed. Now we're waiting a word from you all on acquisition of signal from Athena.
Thanks a lot, John. We're still listening in to Intuitive Machines' Nova Control.
I am status waiting for 1909 for our window to open for visibility on the first station.
That's flight controllers waiting for that window to start listening in for Athena to make that call home. We're just about inside of that expected window for her to make that first call to you. We expect Athena.
We're still standing by for connection with TNOC, is that correct?
That's good readback.
I'm getting.
Should I enable randomization?
Yeah, we're getting some information. We're waiting for visibility at our first ground station to hear. Those are the large radio astronomy dishes on Earth that are needed to make that connection to Athena out in space. What she's doing right now is autonomously commissioning. That's a process where she's turning on her power systems, getting into max power attitude. That's pointing that top deck solar array right at the sun, making sure we're getting good power coming through. Again, I'm just getting a little bit of information here that the visibility of the first station, that first ground station to make that connection with Athena, 1909. So probably here just in the next couple of minutes, Mission Control is just going to be standing by for that opportunity. Until that window comes,
6 minutes post-up.
We're not going to hear that confirmation until that ground station's ready to receive that signal.
Now, Josh,
Copy that.
what
And Tom, we're expecting 1909 for the visibility. That's correct.
It's 1909. They're talking in Central Time, so that's 8:07 here on the East Coast. So here, just a couple minutes away, flight controllers are watching their screens, waiting to make that first connection with Athena while she's been autonomously commissioning herself in space. That process of getting to max power attitude, getting her radio pairs on, and making that first call home, all while moving just about 24,000 miles per hour.
a lot.
That's right.
Now, Josh, what happens if Athena exceeds that time window?
Well, if Athena exceeds that time window, it's okay. She's also programmed to swap radios and antenna pairs to get in a better configuration to make first contact with flight controllers that your folks at home are watching on the left side of your screen. That's Nova Control in Houston, Texas.
Seven minutes, 25 seconds past that.
Copy that.
That's 7 minutes and 25 seconds since we watched
You are
Athena
halfway
separate.
to trip and fitter.
I understand. We should be getting a call shortly from TNOC to connect.
All right, that's a good call from our activity deck director. That's John Graves, waiting for our ground station to connect to Athena as we continue to watch video from the second stage. That's SpaceX on the right and Intuitive Machines on the left. We'll see, what time do we have here? About 8:08 p.m. Eastern Standard. We're standing by for the ground stations on Earth to receive the signal that we expect. Athena is ready and already making that call back through that autonomous commissioning process. Tahira, you touched on what happens if we don't make this connection. It's going to be all right.
It's okay. Okay, good.
Now, we heard a call from Mission Control talking about a comm fitter being halfway through its cycle. What they're talking about there, Tahira, when we say it'll be okay, it's starting.
Back to me, Goose. Ground out. What are we seeing? Is TNOC giving you any feedback? Tom, while they're working that, when is visibility open for Okinawa?
1:29. All right, so we're listening in to when those ground stations will have coverage to connect with Athena in space.
What about DSS 34?
Let's go ahead and toss it back to John and Yome in Hawthorne, California.
In 5 minutes.
We are 9 minutes, 30 seconds past that.
Copy that. And FM.
Oh, thanks,
15
Josh.
minutes and it just swaps towels, right?
Now we're hearing comms in the background right now. Yes. Now, for those of you following along, you'll know that this mission marks our 24th launch of the year. And we're gearing up for the Sphere X and Punch mission, launching from Vandenberg Space Force Base very soon. And in the coming weeks, NASA's Crew 10 mission to the International Space Station.
You know, always follow along at SpaceX.com launches for up-to-date missions and schedules. And before we sign off here at SpaceX, let's go back to Tahira and Josh at Kennedy.
Thanks a lot, John and Yome.
So if you think we can do that and get at least a Farm B up there, that would be great.
All right, Tahir, we have exceeded our nominal acquisition of signal timing estimate, and flight controllers are starting that new set of procedures that will continue over the next several minutes. They're working to confirm our communications configuration is correct, that the flown trajectory we receive from SpaceX matches those expectations, and that our ground station dish is using the right trajectory. That's been a lot of the timing and things that we've heard in chatter right there in mission control.
All right, and we are watching flight controllers in Nova Control right now, working to confirm where Nova sees separated from the launch vehicle, and then matching that data to the ground station's dish that's currently working to acquire the lander's signal.
And the team's expected to continue this process for several minutes until Athena's autonomous procedures start a new process. We've heard them call out a couple times of how much time is left until ComFitter, and that is part of that new process to communicate back to Earth. This includes cycling Athena's power systems, switching radios, and swapping antennas to sets that have not been used yet. All at the same time, we're working with SpaceX to confirm a good launch vehicle separation. That means a good translunar orbit. We mentioned that at the
How
top
long
of
would
the
it
show.
take us to configure the DSN data connection?
Go ahead and turn it on. It should be on now.
Okay, ground net.
And that's our ground net trying to work the ground stations that are on Earth to make that connection with Athena. But right now, we know that Athena...
Just passing 12 minutes in set. We have 4.5 minutes before ComFitter trips.
Copy, thanks, FM.
We know that...
3 minutes. Let's move.
We know that Athena is on a fastball shot toward the moon. That's that translunar orbit. It does give us a lot of flexibility within our flight path.
DSS 34.
And there's some more calls working with those ground stations, enabling the ground stations to make the calls and make that connection with Athena.
That is the start bed.
All right.
We're going to continue to monitor progress inside of Nova Control.
I have command active for DSS 34.
All right.
Telemetry. Setting command off.
All right, so as we continue to monitor progress inside of Nova Control, we're going to pause to continue listening into what folks are saying inside of Mission Control. But let's just recap what happened leading up to and after liftoff from Launch Complex 39A at NASA's Kennedy Space Center. We saw liftoff to here just around 7:17 p.m. Eastern Standard Time. Then we saw a really good shot there.
Beautiful.
Yeah.
Enabled DSS 34B.
I believe DSS 34B is another ground station within the Deep Space Network, possibly.
Telemetry active.
All right, are we getting updates?
I don't see packets yet.
All right, that's a key word there. We're waiting for packets. That means that we're receiving data packets down from Athena. Just about 8.5 minutes after launch, we did see that great booster
14
landing
minutes past that.
on a drone ship. And then a second stage startup just about 36.5 minutes after launch. We saw Athena at launch vehicle separation.
All right, ground net, what do we need to do to get telemetry packets?
I'm not sure. We should be seeing them now.
All right.
All right, we're standing by for data packets. Everyone glued to their screens here. We had launch vehicle separation with Athena just shy of 43 minutes after launch. Nominal acquisition of signal about 5 to 7 minutes. We've exceeded that time. We touched on that autonomous process of what Athena is doing, but right now it's more of a manual process inside of Mission Control as those flight controllers are working to configure the ground stations that are required to make that call. It's possible that Athena is powered on.
All right, so while TNOC is working, looking for anything we can shake on the DSN side to get packets.
And so, Josh, we've mentioned a few different ground stations tonight. If they get this signal from any of them, does that work?
Yeah, it sounds like they're switching over ground stations as we're listening in. I'm not familiar with which one and where they're working those, but they're working to get that signal from Athena, and that's coming from our ground net. And you can see folks working inside of Mission Control trying to solve this problem inside of our circular design control room, allowing folks to kind of wheel around and get the information that they need.
FM, so we're expecting about a minute for the power cycle, and then another 15. Sitting there looking, same antenna config.
30 seconds to the power cycle is what I got.
Copy. Okay.
All right, as we enter this,
Call it out, we'll start a timer.
as we enter this power cycle, we're going to continue to work that autonomous process with Athena.
We're at 16, 17 is what I'm showing. Is that what we got?
I'm now at 16, 17 right now.
Okay. Copy. Granite, give us calls on the main loop. You are the most important person in the room. Everything you're doing is critical. Call it on the loop, everything you see.
All right, as we hit this repowering process, it's going to start several long terms where
Background net, everything goes on the main loop.
it'll give Athena some time to configure her systems if that's what's required, but it's also going to be some time gaps.
34B. Do we have control in the room?
It's also going to be some time gaps in between when we can configure these ground stations.
Raven. Yep.
It's going to start opening up longer periods of when we're waiting for autonomous processes as well as
data control to make sure they're seeing packets for us.
They have carrier lock, sub-carrier lock, symbol lock, but no telemetry.
But they have no telemetry.
Copy.
All right, that's a good sign. We're hearing carrier lock. That's one of the steps that we heard on our first lunar mission.
I need to borrow some of these fellas.
Showing packets.
All right, we're showing packets. All right.
Oh my goodness.
Everybody wake up.
Got to keep you on your toes, all right? We're going to start Athena here, and that is a great call. That is an active situation where we're switching ground stations in order to make contact with Athena. Kept us on our toes. I feel a little flushed in the face with getting those data packets and getting that confirmation from Mission Control. Best news I heard all night. I didn't think anything was going to top watching that launch, Tahira.
So, Josh, can we breathe easy now?
Orange Groundnet, can I?
We can. It sounds like we have our packets and we're working those challenges, but the important thing is we'll be providing those updates on our page as well as
packets?
on our X account as they continue to work this challenge. But what an action-packed moment. 3 rideshare deployments
Take a look at what you got.
and Athena's first call home to let us know she's ready for her lunar journey. And we continue to know that this is a journey filled with challenges, and successfully acquiring Athena's signal and getting those packets and maybe having some more challenges, we know that those are the steps toward getting the ultimate milestone, landing and operating on the lunar surface, Tahira.
I mean, again, like you said, what an action-packed moment. So glad to get that call out. Now, Josh, can you tell us what is next for Athena? You know, can you give us any details on lunar landing?
Well, with today's launch, we expect Athena to land about 8 days from now on March 6th. After vehicle checkouts tonight, we hope to send Athena's selfies with Earth in the background and capture new images along her journey. Over the first 5 days en route to the moon, she'll perform multiple small engine firings to hone in her trajectory toward the moon before committing to lunar orbit insertion. That's about an 11-minute burn to slow the lander down to get captured into lunar orbit. We expect to send another batch of lunar selfies back to Earth during Athena's few days. That's right. And finally, on March 6th, somewhere around lunchtime Eastern, we expect Athena to make a landing attempt and, if all goes to plan, spend about 10 days conducting lunar surface operations.
Well, best of luck, Josh. That's going to wrap up NASA, Intuitive Machines, and SpaceX coverage of the launch of Intuitive Machines moonlander Athena on a SpaceX Falcon 9 rocket from Pad 39A here at Kennedy Space Center.
And again, if all goes well, Athena is expected to land on the moon 8 days from now on March 6th.
And we will bring you that coverage live right here on NASA Plus. Until then, you can find out more information about this mission and other NASA Eclipse launches by scanning the QR code on your screen or by visiting nasa.gov/Eclipse. Now, we will leave you with a replay of tonight's launch. From everyone here at NASA, Josh Marshall and Intuitive Machines and SpaceX, I'm Tahira Allen. Have a great night.
T-minus 15. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon, go Intuitive Machine.
Diesel is pitching downrange.
And when the propulsion is nominal.